Hi, I'd like to show you DLT's new REST API source. This source has been allowing us to build data pipelines in very little time and very little code. We've been using it in consulting projects over the past weeks. We found that we were able to build data imports in much less time, and also it reduced the code needed dramatically. And that's why I'd like to share now the great work from the people at DLT Hub. The simple-most pipeline to import a REST API source looks like this. We have a base URL for the REST API, and then we define different endpoints that we want to import. Let me show you how it looks like. For this example, I'm going to use the Poker API, and I'm going to use the berry endpoint for it. The data this endpoint returns looks as follows. We have 64 berries in total, and we get the name and the URL for each berry. Now to import this endpoint, everything we need to do is to write berry, which is the endpoint, into this list of resources. Before we can run this pipeline, we first need to install DLT and its dependencies, as well as the REST API source. I'm using Poetry for this project to manage dependencies and also the virtual environment. So I'm going to run Poetry install. All dependencies are specified in the pipe project toml, and the important thing here is that we need a DLT version which is at least 0.4.7, which is where the REST API landed, and then we need DuckDB as our data destination and also the DLT CLI. To get this REST API source, we need to install it first. And we install it by using the same mechanism DLT uses for all verified sources. This is how our repository looks like. And after typing DLT init REST API DuckDB, we now have the REST API source here, the full source code available. Now we're ready to run the pipeline. To run this pipeline, we just execute this Python script pokemonpipeline.py. And we see that 64 berries were loaded exactly as we have seen it in the API Explorer in our web browser here. Great, let's inspect the data. I'm going to use the DuckDB command line interface and open the database that just got created here. This is the file. Now we see that the berry table was loaded, just like metadata tables that DLT uses internally. And by selecting all berries, we see that the data here is loaded indeed. Good, I'm going to close this. Now, if I run this pipeline again, I will see a problem. The problem is that again 64 berries were loaded. And now we have 128 berries loaded in our database. The reason is that by default, every DLT resource appends the loaded data. Therefore, I'm going to drop the table. And I'm going to specify that the right disposition for the berry resource should be replace and not append. Now I specified that the right disposition should be replace, and the endpoint is /berry, so base URL /berry, and then I'm also going to change the name of our resource into berries so that the table name will be berries and not berry in singular. Let's run the pipeline. Great. So again, we have 64 berries. And now we see that there's a table called berries. And we have 64 rows. Now let's load again. And now, even after having run the pipeline twice, we see that there are only 64 rows. So no duplicates anymore because we specified the right disposition correctly. Now let's go ahead and add more endpoints. The Poker API has multiple endpoints available. For example, /Pokemon. /Pokemon gives a list of Pokemon So again, everything we need to do is add the string Pokemon, and the REST API will construct the resource. Now we notice that running this pipeline took more time than importing just the berries. The reason is that by default the /Pokemon endpoint returns only 20 Pokemon, but in order to fetch the 1300 Pokemon, multiple requests are necessary. To accelerate the loading, we can give a limit parameter like this. By specifying limit 1000, we will get the first 1000 Pokemon. Now I could transform this resource specification into a dictionary, just like I did for the berries, and provide the additional URL parameter for the Pokemon endpoint. However, I'd like to benefit from the increased page size for all resources, and therefore I'm going to put this into the defaults for all resources. With the following code, I have specified now that for each endpoint it should add the limit parameter and give it the value of 1000. Also, I want to avoid that I get duplicate Pokemon when I run the pipeline multiple times. Therefore, I will also refactor the write disposition replace into the resource default description. I'm going to add this here right on top, and now I can execute the pipeline again. And now we will see, now we could see that the Pokemon got loaded much faster. Indeed, it took only 0.62 seconds to load all of them, because now only 2 requests were necessary. Often REST APIs are structured in a way that we have one resource, let's say /berry, and then a sub-resource where additional information about this specific berry can be loaded. For example, here, the additional details for the cherry berry are available under this resource, /1. And we see that we have now firmness, flavors, etc. available. Now, how can we do this using the DLT's REST API source? Everything we need to do is we add another resource here, which we will call the berry details. The endpoint will be /berry/berry name, and the berry name and the parameter berry name is a resolve parameter from the berries resource and the field name. What this tells to the REST API source is to create a DLT resource So what this tells to DLT is that for each berry, take the name and put it into this endpoint. And in addition to /berry/1, we can also query the details like this, /berry/cherry, and this is equivalent. Because again, we see all the 5 flavors here. Now let's execute the pipeline. And we see that now step by step it loads the berry details for each of the 64 berries. That's why it takes now a little bit longer, and this default limit parameter of 1000 doesn't help us because every berry endpoint gives details only for one single berry. Great, so now after 43 seconds, in my case, we could load all the 64 berry details, making these 64 requests. Again, let's inspect the data. Here we have our 64 berries, and now we also have berry details. And we have 64 berry details. Now we have more tables than just the berries and berry details and Pokemon, because DLT automatically normalizes the nested JSON that is returned by the API. That means everything that is a list, such as the flavors that we saw earlier, here they are. Here's a list of 5 items. They get their own table. And this is what we see here. Now, by looking at the berries, I realize that the only data that is here is the name and the URL. And the name is also visible in the berry details table. Therefore, I can say now to DLT that I don't need to load the berry resource into my destination. The code I need for this is I write selected false. And now DLT will refrain from loading the berries table. To prove it, I'm going to drop the table berries. Run the pipeline again. And now when I inspect the database, I see that there's no berries table anymore. This concludes our tutorial on DLT's new REST API source. We saw that with this little code, we could import 3 different endpoints, and from that declarative specification, DLT automatically constructed resources, and we could also specify additional resource specifications such as the name of the resulting table or whether this table should be loaded into the destination or not. We also saw how to specify dependent child resources, which take a parameter from the parent resource. And we also saw how to specify resource defaults to avoid repeating ourselves. This was the first tutorial in a series of tutorials in which we explain the most important features of the REST API source. If you found this interesting, then I recommend checking out the source code repository that we linked in the video description below. I also invite you to join the next tutorials where we showcase features such as incremental loading and authentication. Therefore, see you in the next tutorials. Bye!